how are you? Hope things are going well for you. Today I'm recording in my room, so this is a different feel for me. So you won't hear any barking dogs, but you might hear a desk or two move around. We have been working with ratios and proportions, which are all over our universe here. And today we're going to learn to find unit prices for comparing things. This helps when you're grocery shopping. And we're going to also do other proportional applications. So here we go. When you're talking about unit pricing, this is an application of ratios, and what you're doing is you're finding the price for 1 unit of your product. All right, 1 unit of your product. Your unit could be a piece, it could be an ounce, it could be a gram, it could be a gallon, it could be a mile. So there's all kinds of ways to approach this. When you're doing unit pricing, always put your dollar amount on the top, because it's going to be cost per 1 unit. You'll put the quantity is always going to go on the bottom. Dollar goes on top. Quantity always goes on bottom. And then you're going to reduce to a unit by making sure, by dividing top and bottom by whatever number it takes for the denominator to be 1. And we're going to do this so that we can be good stewards of our money. Oh, look, be a smart shopper. So let's try this. All right, let's just try it in a table format before we start looking at a whole bunch of words. Find the unit price for each size of syrup, doing this one right here, and determine which one is a better deal. So I have a 36-ounce jar that costs me $3.89. I have a 24-ounce jar that costs me $2.79, and I have a 12-ounce jar that costs me $1.89. So my unit of products is ounces, all right? My dollar amount for the first one is $3.89. Oh, I need to change my pen, sorry. $3.89, and then the number of units I get for that is 36. And when I do that on a calculator, I get about 11 cents. $0.11, that's 11 cents. All right. Now for the 24-ounce jar, I'm going to take $2.79 and I am going to divide it by 24. And when I do that, I get 12 cents. So not much difference unless you're buying huge quantities. And then I have $1.89 divided by 12, and that is 16 cents. All right? So there's not a lot of difference in the unit price between the 24 and the 36, but there's a huge difference with that 12, all right? And be careful when you're shopping, because sometimes they'll run specials on the smaller sizes, and this won't be such a huge difference. So be a smart shopper, all right? This is, oh, my favorite. Find the unit price for each size of Nutella. Ooh, girls, we're doing Nutella. I love Nutella. And determine which one is a better deal. All right, better deal. So I have an 18-ounce jar for $3. I have a 40-ounce jar for $5 and a 64-ounce jar for $8.75. So now I'm going to find my unit price by taking the ratio of my dollars, $3 divided by 18. And then this one would be $5 divided by 40. And this one would be $8.75 divided by 64. Grab a calculator. This is 17 cents an ounce per ounce. These are actually per ounce too. Probably want to use units. The 40-ounce jar is 12 cents per ounce. And then the 64-ounce jar, well, look at here. This is 14 cents an ounce. There must be a special on the 40-ounce one. Okay? So our best bet would be the 40-ounce jar for 12 cents an ounce. All right? There's lots of other ways we use proportions and unit pricing. So let's do a couple of them. The rest of them are a bunch of just different examples. After pumping 5 gallons of gas, the price on the pump read $16.60. After filling up, the price on the pump read $48.14. How many gallons of gas was pumped? All right, so again, we're going to read to identify. What am I looking for? I'm looking for number of gallons. Number of gallons. Okay, so that's what X is going to be. X will equal gallons. And then we're going to write a proportion. All right? Let's use our unit pricing. We have $16.60 divided by 5 has to equal, we don't know how many gallons, so gallons goes down here, and then we paid $48.14. Now all we have to do is cross multiply and solve for the variable. So I get 1660 x equals 5 times 48.14. All right, so 5 times 48.14 is 240.70. And then I'm going to end up dividing that by 1660. And I get 14.5 gallons. Just like that, 14.5 gallons. Okay? Now, to check it, you would take 48.14 divided by 14.5. And that gives you 3.32 per gallon. And then you would have 1660 divided by 5. And that gives you 3.32 per gallon. All right, so it worked. Why don't you try this one and then come back and see if you got it right. All right, welcome back. 12 gallons of fuel costs $37.68. How much would 16.5 gallons of the same fuel cost? What are we looking for? We're looking for cost. So we're looking for money. All right? Assign a variable. X is going to equal the dollar amount. Dollar amount. Okay? Write a proportion. I know that 37.68 is the price for 12 gallons. And then I'm looking for the dollar amount for 16.5 gallons. Okay, I'm going to cross multiply, and I get 12x is equal to 3768 times 16.5. So this is 621.72, and then I'm going to divide that by 12. And I get $51.81. All right? So 16.5 gallons is going to cost $51.81. If 14 candy bars cost $20, how much will 32 candy bars cost? So you're looking for the dollar amount. So X is going to go in the money spot. You can write it like that. We're going to write a proportion, dollars over units. So I have $20 over 14 has to equal some number over 32, and I'm going to cross multiply. Remember, it's always money over quantity. Money over quantity. 32 times 20. So 14x is equal to, well, 3 times 20 is 600. That should be 640. 640. And then I'm going to divide that by 14. So 32 candy bars will be $45.71. Like that. Right? We can also use proportions with distance. So it says the distance from Kansas City to Denver, that should be 2. To Denver is 600 miles. On a map, this distance is only 11 inches. If the distance between Memphis and Philadelphia is 1,000 miles, how far apart are the cities on the map? So we know that, what are we identifying? The distance in miles, right? Distance in miles. So that's what our X is going to be. X will be in the miles. Okay? All right? Now we're going to write a proportion. Okay? We're going to write 600 miles is the equivalent of 11 inches. Okay? Oops, sorry. We're looking for inches. Distance in inches. My bad. Inches. I read it wrong. Okay? And then it says the distance between Memphis and Philadelphia is 1,000 miles. And we're looking for the number of inches. That's our X. So we're going to cross multiply. So I have 600X is equal to 11,000. And then I'm going to divide by 600. And I have 18.3 inches. A wall map shows a distance of 17 inches between Memphis and Denver, which are actually 1,040 miles apart. If the actual distance between St. Louis and Des Moines is 333, how far apart are they on the map? What are we looking for? We're looking for distance on the map. That's inches. Map distance. So that's what X is going to be. Inches. Write a proportion. So I have miles over inches has to equal miles over inches. and then we just cross multiply. 1040x is equal to 5661, and then divide 5661 by 1040. And so our inches are going to be 5.44 inches. All right, our recipe calls for 3/4 cup of sugar to make a batch of 21 cookies. How much sugar is needed to make 60 cookies, okay? So this is just a shy, 21 is just under 2 dozen cookies, and this is 5 dozen cookies. So for this particular problem, I'm going to take 3/4 and write it as a decimal, right? I'm looking for the number of cups of sugar. Mrs. Pilger will appreciate this one. Assign a variable. Well, x is going to be the amount of sugar. Amount of sugar. Write a proportion. Well, I know that 3/4 cup, 0.75, gives me 21 cookies. So how many cups is going to give me 60 cookies? That's it. Now do cross multiplication. So I have 60 times 0.75 is equal to 21x. So I get 45 is equal to 21x. Then I'm going to divide by 21, and it says that I need 2.1 cups of sugar. Just like that. Ooh. Oh, he didn't come back up. Huh, I have to fix that. It says C is for cookies. That's good enough for me. Woohoo. My nephew used to say that. All right. Okay, last application. Using proportions with similar triangles. We saw this in geometry, but I want to recap this for you. All right. The trick to this is just keep your triangles going in the same order on both sides of the equation. So take a side from the big triangle, and then take the corresponding side from the smaller triangle, and then do that same thing with 2 other sides. All right? It doesn't matter if you go big over small or small over big. Notice I have it over here too, as small over big. Doesn't matter. I think I'm more of a small over big. As long as both sides are exactly the same, you're good to go. Okay? So we just need to write a proportion. All right? We're looking for this piece right here. All right? So this is my small, so I'm going to have x. And what side corresponds to x? Well, it's this one right here, the 16. So x over 16. I went small over big, has to equal. Now pick another pair of corresponding sides. Here's 5 and 20, right? Has to be, and we did small over big, 5 over 20. Now cross multiply. 20x is equal to 5 times 16 is 80. So x is equal to 4. I'll put down here, this is 5 times 16, so you guys can see where I got that from. Okay? So x is equal to 4. And then you just check it. Is 4 over x, 4 over 16, that's a fourth, and 5 over 20, that's a fourth. So it's the same ratio. So they're proportional. Okay, you try this one and come back and see what you get. All right, I'm looking for this x on my big triangle, and that corresponds to that 4. So I'm going to go big over small this time, just because I can. X over 4. Now I'm going to take another pair of corresponding sides. I'm going to use this 3, and it corresponds with this 2 right here. So it's 3 over 2. So I'm going to cross multiply, and I get 2x is equal to 3 times 4. 2x is equal to 12. X is equal to 6. And then 6 over 4, if you reduce that, you get 3/2, and it works. These are the problems that we're going to be doing in class. It's not a lot of them, but you see that they do take a little bit more time. So please come prepared if you need to watch it again. Have a good evening, and I will see you in the morning. Bye.